All right, let's jump right in. We all know the EV revolution runs on batteries, but the real brain, the unsung hero inside that battery, is the BMS. The thing is, the entire concept of the BMS is being turned on its head. So what we're going to do here is walk through its new mission, the tech revolutionizing it, and what it all means for you. This is your game plan for what's coming. So let's start with the conclusion first, the big takeaway. The job of the battery management system has fundamentally changed. We've graduated from building simple watchdogs that just, bark if a voltage gets too high. The new mission? We are building predictive brains, and their prime directive is a zero-tolerance policy for thermal runaway.
Now, this isn't just semantics. It's a complete shift in how we think about battery safety. And why is that? Well, it's because our traditional methods are just too slow. By the time they see a fire, the house is already burning down. Let's look at the timeline and you'll see exactly what I mean.
Okay, look at this. The whole catastrophic event from the point where you can't stop it to a total failure happens in minutes, seconds even. So if you're waiting for a temperature sensor to go off, you're already way past the point of no return. The only place we can actually win this fight is way back here, in the early detection window. We're talking days, sometimes weeks, before the disaster, where the only clues are these teeny tiny micro-voltage anomalies.
So the big question is, how on earth do you detect something so small? How do you find a needle in a haystack of data? Well, that brings us to the software, to the algorithmic layer. This is where the real magic is happening and, frankly, where the biggest competitive advantage lies right now.
The old way was, let's be honest, pretty basic. It was completely reactive. The temperature hits a certain number, you trigger an alarm. Simple, but way too late. The new way is all about prediction. It's about using sophisticated algorithms to spot the faint digital fingerprints of a future failure, like a tiny internal short, long before it ever gets hot.
But of course, there's no silver bullet here. There's no one algorithm to rule them all. What you're looking at is the toolkit and the trade-offs that every single engineering team has to make. You've got your lightweight, low-cost stuff like recursive least squares, which is great for a first pass. Then you have things like Shannon entropy, which, interestingly, is amazing at finding problems when the car is just sitting there, parked. And then you have the heavy hitters, AI models like autoencoders. They have unbelievable predictive power, but man, do they require some serious compute. The winning strategy? It's a layered defense. You use a mix of these tools.
So just how precise are we talking? Get this, a well-trained autoencoder can spot an average voltage deviation of just 6.8 millivolts. That is an incredibly small signal, and it can use that signal to predict a major fault 8 days before it happens. Think about that, 8 days. This level of foresight completely rewrites the rulebook on EV safety.
Now, all this amazing new intelligence, this predictive brain, it can't run on yesterday's hardware. It needs a new home. And that's driving a total revolution in the physical architecture of the battery pack. So let's look at the hardware.
I mean, think about it. You've got this massive, complex, heavy wiring harness in every battery. How do you get rid of all those problems? The answer is as simple as it is transformative. You just cut the cord. And that's exactly why wireless BMS is taking off so fast.
And the benefits here are just huge. I mean, sure, you lose weight, that's obvious, but the really big deal is that you can now have fully automated robotic assembly. You get rid of the wires, you get more space inside the pack for cells, which means more energy density. It makes the pack easier to service, and this is a big one, it makes it possible to track data for every cell from the day it's made to the day it's recycled. That's a game changer for regulations and second life applications.
But it's not all easy. This revolution has its own set of massive challenges. As we all move to 800-volt systems with these super-fast silicon carbide inverters, the inside of that battery pack becomes, well, an electromagnetic war zone. We're talking 3, maybe 4 times more noise. It's an absolute nightmare for reliable communication, whether you're wired or wireless. Solving this is a top-tier engineering challenge for everyone right now.
Okay, so these incredible technical shifts aren't happening in a bubble. They're playing out on a global stage that's getting more and more complex, with fierce competition and some really tough new rules that are changing the entire market.
And for any team that wants to sell cars in Europe, this timeline is your new Bible. It's totally non-negotiable. By 2027, which is right around the corner, every single EV battery needs a digital passport. It has to track its entire life story. This means your BMS architecture, the one you're designing today, has to be ready for this level of data tracking.
At the same time, just look at how the competitive map is being redrawn.
This snapshot from China tells a really clear story: vertical integration. The big OEMs like BYD and Tesla are taking control. They're bringing BMS design completely in-house. Why? Because they know that owning the hardware, the software, and those critical algorithms is the key to winning on performance, cost, and speed.
Okay, so let's pull all of this together. What does this actually mean for you and your engineering teams over the next 24 months? Here's what we see as a clear, actionable roadmap.
First things first, stop blowing up batteries to validate your algorithms. It's dangerous, it's expensive, and it doesn't even give you the best data. You have to shift to a high-fidelity virtual test bench. And second, you need to become masters of the idle state. That time when the car is parked isn't downtime, it's a golden opportunity. It's the perfect time to run those lightweight algorithms and hunt for those tiny signs of trouble.
Next up, your AI and data strategy. You've got to think in tiers. Put the lightweight, nimble AI models right at the edge. On the cell microcontrollers, save your big, heavy-duty neural networks for the powerful zonal computers. And this is absolutely crucial. You have to build that data loop. Connect the data from the factory floor with the data from cars on the road. That's how you continuously make your AI models smarter.
And finally, architecture and compliance. You have to engineer for that noisy 800-volt world from day one. That means mandating robust digital isolation. And don't wait on the battery passport. Build the software hooks for it now. Future-proof your design. And embrace a software-defined approach like Adaptive AutoSAR. You need to decouple your brilliant application software from the underlying hardware so you can update and innovate on the fly.
Which brings us to one final, really provocative thought. If you look at all these trends, the AI, the wireless tech, the move to zonal architectures, they all point to one inescapable conclusion. The standalone BMS is dying. It's dissolving, its functions are being absorbed by the vehicle's main computers. So the real question you should be asking isn't how do we build a better BMS for tomorrow, it's what new system will we be designing in its place come 2030?